Welcome. So what we're going to do is we're going to show you how to, I'm going to show you how to solve this quadratic equation by completing the square. And the main important thing that I'm going to do with this problem is we're going to notice that this is very similar to a lot of our problems that we've had. We need to complete the square, and we see that our a is going to equal 1, but we're going to have a little difference because we're going to start introducing a little bit more fractions. And you can say, well, there's no fractions going on over here. And just wait, let's go through the process and see. So the first thing we need to do is we need to, when we're solving this, we're going to set our output value equal to 0, and we want to find the values of x that are going to make this equation true. So the first thing, we set up our quadratic on linear terms into a in parentheses, and then we want to now create the value of c that's going to make this a perfect square. So remember, we have to do our b divided by 2 and square it. So I take 5 divided by 2 and square it. So therefore, 5 divided by 2 squared leaves me with 25 over 4, which is a lovely, lovely fraction. And I can't simplify this anymore, so I need to make sure I add this to both sides, the right and the left side, or I could add and subtract on the same side. But I'll just add it on both sides. So I add 25 over 4 to the left side, which plus 0 is just going to leave me 25 over 4, times x squared plus 5x plus 25 over 4 minus 3. Now, this is where it gets very, very confusing for a lot of students, is they're trying to think, they're like, okay, how do I now factor this, right? It was very simple when you had a perfect square trinomial with, rational, or not with rational, with integers. We could go back and factor it by using our regular factoring technique. And you can still use your regular factoring technique for this, but a lot of students get kind of confused. So I want to kind of give you a little bit of help here. If I have my quadratic x squared plus bx plus c, all right, and I want to be able to figure out what is going to be, if this is a perfect square, and I want to figure out what is going to be my binomial factor, there's a couple different ways to write this. Well, one, we know that this is always going to be, if this is a perfect square trinomial, then this is going to be the square root of c, square root of c, times 2. So we could have x squared, let's do 2 of them, x squared minus bx plus c. So therefore, this really is x squared plus 2 times the square root of cx plus c. And this is going to be x squared minus 2 square root of cx plus c. Now remember, this is all I'm only right now just showing you if these are perfect square trinomials. Because remember, perfect square trinomials, your c value has to be a perfect square number, and then your middle term has to be double the square root of that value. So therefore, the factored form of this is just going to be x plus 2 square root of c. And this one would be x minus squared, x minus 2 square root, x plus the square root of c. And this one's going to be, what am I doing? X minus the square root of c squared. All right, so that's one way to factor them out. The other way to look at this is if I took b divided by 2, that is taking that and dividing it by 2. So if I just take my x divided by 2 and then add those up, that's what's going to give me my thing. So I can actually factor this. Also, another way to look at this is to take x plus or minus b divided by 2. All right. So if I just take my x plus or minus my b divided by 2, that's another way that you can rewrite your factored form for this. So if I look at this, my b divided by 2 is equal to 5/2. And since this is positive, I'm going to use the positive version of this. So I still have 25 over 4 equals x plus 5/2 squared. And I can just go and double check my work. Does 5/2 times 5/2 gives me 25 over 4? Yes. Does 5/2 plus 5/2 give me 10? Well, 5/2 plus 5/2 is 10, or give me 5. Is 5/2 plus 5/2? That gives me 10/2, which is 5. So therefore, that is a way to work. So there's really kind of two ways I was telling you. You could either use this b divided by 2, just take whatever your b divided by 2 is, and then plus or minus, depending on what your middle term is. Or if you're going back to our formula for a perfect square, you could also look at it in that format as well. All right, so anyways, what we're going to look at here is we still have a minus 3. So now we're going to get into the fun part. All right, I know the factoring sometimes gets confusing for students, so I gave you kind of two versions to look at. But now we got to go ahead and still isolate our variable. So we're going to add 3. But now I have 25 over 4 plus 3. So remember, when adding a fraction to a whole number, we got to make sure we have the same denominator. So this is really 3 over 1, but I need to multiply by 4 over 4. So therefore, I'll have 25 over 4 plus 12 over 4. Follow? Good. Let's put a little parentheses. OK, so I'm multiplying those together. So therefore, now I'm going to have 37 over 4 equals x plus 5/2 squared. Now I need to undo the square root. So I'm going to take the square root. Let's use red. I kind of like that red. So now I'm going to take the square root of both sides. And remember, when taking the square root of a rational number, the square root of a rational number can be broken down. 37 over 4 can be broken down as the square root of 37 over the square root of 4. And I show you that because we can take the square root of 4, which is 2. Now remember, also, I'm taking the square root, so I need to make sure I include the plus or minus. Now the square root and the squaring are going to undo each other. So therefore, I'm just going to be left with plus or minus the square root of 37 over 2 equals x plus 5/2. Then I'll subtract 5/2. So minus 5/2. I'm kind of running out of room, so let's work over here. So therefore, even though these are the same terms, I cannot combine the square root of 37 and the negative 5. So my final answer is going to be x equals, and I'm going to write them under the same denominator, as a negative 5 plus or minus the square root of 37 all over 2, since they have a common denominator. Now, you could break that up, and if you write 2, but we like to write the simplified version. We like to write it as a single quantity if we can. However, you could also look at it like that, and it'd still be the same. All right, ladies and gentlemen, that is how you solve by completing the square with a little bit of fractions. Thanks.